Hello everyone, this is Rohan Meshram, and in this video I will tell you how to run MD simulation on Google Colab. Specifically, I will tell how to run NAMD on Google Colab. So first let me tell you about this video. In this video, I assume that you have working knowledge of MD simulation and you know how to set up and run the MD simulation on PC or cluster using NAMD. If you don't have, then maybe you should check out my videos on setting up the MD simulation and running them. I would also advise you that you watch a separate playlist on theoretical details of MD simulation. The link to the playlist is in the description box given below. So here I demonstrate you how to run MD simulation using NAMD on a cloud platform Google Colab, and later on we will compare the performance of running the same on the desktop PC. So this is the dual activity that we are going to do: run our NAMD simulation on Google Colab and then compare it with the uh, the same simulation that was already we ran on desktop PC. So let us first discuss as to why is that I need to shift on a cloud for MD simulation. So there are a lot of situational and practical difficulties one can come across while doing MD projects. One of the first and foremost difficulty that people usually face is that it is like, I don't have the fast PC to conduct MD simulation, what do I do, right? Or sometimes there are other factors like there might be very heavy load on cluster during busy semester. Computation time gets distributed and you might end up taking more time for completing the simulation. You might have dependency on institute for high performance machines. If you are out of your institution, then MD work stop because you don't have fast PC to do the simulation alternatively. Other factors that might influence the MD simulation project is like power supply. uh, uh, you know, a space on cluster may also limit your project. And finally, faster machine means more money to invest in buying those PCs. So if you use cloud platform, the cost is eventually reduced. So most of these problems that I have just discussed, they can be bypassed if you start using cloud computing for performing such MD simulations. So before we begin, let me thank my student who explored the possibility of using cloud computing in MD simulation. I would like to thank Pooja Gaidani and Shivani Elpure. If you are watching this video, thank you for making this happen. I have always been blessed with these remarkable and talented kids in my life, in my lab. So let me tell you as to what is exactly cloud computing before we start using it. Right. So simply put, Google is providing you access to fast computation machine. It will be like working on someone else's computer located in an entirely different continent. The other computer has Linux operating system installed, and hence you can use all the Linux command that are offered. Google provides you one GPU and CPU for free for your computation for a specific time frame. So all you need is a Google account and you are ready to roll to use this high performance facility. People generally use cloud computing platform for machine learning. So now this Google Colab is no longer a domain for only machine learning projects. You can also use it for molecular modeling as well, as I am going to demonstrate you in this lecture. So let's begin. So in this video, I will demonstrate you how to use Google Colab for performing MD simulation using NAMD. For this purpose, we will be using protein ligand system and show you how to run a minimization simulation of 600 steps so that we can complete this tutorial in time. So let me now tell you about the system that we are going to use. So the system that we are going to use consists of a PDB file. A PDB file contains the coordinate of our system. Next, we have a PSF file. These are required for NMD. A PSF file that holds topology information as well as atom typing of our system. Thirdly, we have a force field parameter files. This par all 22 parameter file is for protein, and 1101005, this particular parameter file is for ligand. So of course we have this configuration file, as you can see over here. This configuration file tells NAMD as to how to run the simulation. All the commands for running the simulation are present in this configuration file. So if you are new to MD and don't know what these files are and how to generate them, then you should consult my previous video. And here let's just assume that you know how to set up a system. My objective of this video is to introduce you to cloud platform, running the simulation on cloud platform, and not to set up and run the MD simulation. There is a difference, right? So here we will focus only on using how is that we use the cloud platform for running MD simulation. Okay, so here are basic things you need to do for running NAMD on Google Colab. So first thing you might do is to upload all the input file on Google Drive. I have already done that. Whatever input file that I have shown you, those are already loaded on my Google Drive, right? So we will be connecting your drive to the cloud computer for running the simulation. We call it as mounting your drive. So in this way, after you complete your simulation, all the results will be stored on the Google Drive, and you can download those results after you have finished off with your computation. So to do so, to begin with, you can open a new tab. Well, now it is necessary that you use Google Chrome as a browser when you do such MD simulation based on Google Colab platform, right? So if you use Mozilla Firefox or any other browser, it might create some problem. So it is better that you use Google Chrome. So once you open this Google Chrome, first thing you might want to do is to just do this search for Google Colab, and the very first link that might appear is the one that Google uh, colab.research.google.com. This is the link that you are looking for. Okay, so following the first link of Colaboratory, this link was for Colaboratory. So on the Colaboratory page, it will tell you about your previous work that you have done, right? So on Colab we work on notebooks. So therefore you will need to create a new notebook for this project. You can save this notebook and load them next time you visit Colab. You can download these notebooks as IPYNB file or even Python files, and you can share them with your boss and friends. So to create a new notebook, all you need to do is to click on this new notebook icon, and a new notebook will appear that might look something like this. Okay, so let me tell you a little bit about this notebook. uh, every notebook, it has got a feature toolbar with usual file, edit, view, insert, runtime, all the menus and their sub menus. You can explore them on your own. I will just show you what is important pertaining to MD simulation. Once the notebook is loaded, first thing you might want to do is to change the runtime type, right? So if you want to change the runtime type, you might go to this runtime menu, right? and you can use this change runtime type submenu, and a new menu that appears. Well, it shows uh, what is that it is offered for performing computation. So runtime type is that this Google Colab is now supporting Python 3 as a base language. You can change it if you wish, you can change it to R, but we will stick on to Python 3. Then you can select what type of hardware accelerator you want to use. So your Google Colab for time being offer three type of hardware. It offers a CPU, it offers a T4 GPU, and it offers a TPU. Right. So this GPU or graphical processing unit, and TPU, it is also called as tensor processing unit. It's like selecting what processor you might want to use for your computation. GPU is generally used for high performance simulation like one we are going to do, while TPU are optimized for machine learning tasks. So we better use this GPU for running our simulation. So once you select your hardware accelerator, then just click this save button. So clicking on this save button, uh, this will this will kind of tell you that now you would be using GPU for all of your computation. So in this way, all the computation will be carried out on GPU now onwards. So now one more thing that you need to know is that Colab is an interactive platform, and it expect continuous communication from the user through something called as the code cell. This is called as a code cell. You write the command in code cells. If your session remains inactive for a while, the Colab assumes that you are no longer using it, and it will log you out and provide GPU to some other user. Well, we will come to this problem in a while, but for time being, let us proceed for further procedures. Okay. So first thing that we might want to do is that we will now download the NAMD software that we are going to use in our simulation and install it on Google Colab first. So we will download the software from the URL that is provided in the description box below, right? And I have already written those commands over here. Okay, so the very first command that we are going to use is this command, what we call it as wget command, right? All you have to do is to just copy that command and paste it over here. So what is exactly this that this command is giving? This wget command, well, say for example, the exclamatory sign indicates exclamatory sign indicates that the wget command will work on the system command line and not on the Python kernel. Well, just ignore it if you don't dig it anyways. We don't want to get into the programming jargon here. The objective here is to teach you as to how you can install and run an AMD simulation. Okay, so all you have to do is to paste this URL in front of this little code cell and click on the little play button to execute this command. Okay, so all we need to do is to execute this command now. So now since I have not used, it is asking me if I am a robot. It is still executing. The circle will start to revolve as you can see around this play button, right? Indicating that command is in progress, and it will also show you the progress of the command below, as you can see over here. right? Once the command is completed, a green tick will check mark will appear that indicate that the command has finished successfully. It will depend on your internet speed as to how much time it will take to complete the download, right? So it is completely dependent on what kind of internet connectivity is that you have. Okay, so once this thing is done, now you can note that there is this folder icon on the left of your notebook. So clicking on it will let you know that what is it that is present in your working directory, right? So now in your working directory we have successfully downloaded this tar.gz file. Okay, so here you see that you have a tar.gz file, archive file, that you have downloaded using this particular command. Next we need to extract, next you need to extract the content of this archive. We would need we would need a new code cell to give a fresh command. So for giving the next command we would need a code cell, new code cell. So what you can do is you can click on this new code cell so that new code cell appear over here. So next task would be to extract this tar.gz file that we have obtained. Okay, and for extracting we would be using this dash xzf command that is generally used in Linux operating system, right? So what you can do, you can right click on this tar.gz archives in the file section and select the copy path. Select this copy path option. So this will copy the path of the folder. Okay, and once you copy the path of this folder, all you need to do is to type this command like this exclamatory mark and tar dot or you can say dash z xf in the code cell, and let us paste the path of this tar.gz file, right? So all you need to do now is to execute this command, right? So just wait for a while till this green tick appears over here, right? And now you can see that a new folder you know will be produced over here, wherein the wherein the data extracted from this tar.gz file will appear. Okay, so this new folder has appeared over here, and this new folder, so sorry, over here you have got this NAMD2 program that we are going to use for executing our simulation. So everything is really very fine. Okay, so next thing that we need to do now is that we need to mount our drive. And to mount your drive is just like you are connecting your notebook to the Google Drive where you have your own data. For this you would need a new code cell, and to mount your drive I have already written this code over here. All you have to do is to copy this code. This code I will provide in the description box, and then just paste it over here and just hit the execute button. Now it will ask you the permissions. Okay, so in this permission, yes, of course you want to connect to the Google Drive, right? Now it will ask you to what account you need to convert, to what account do you want to connect with. I will use the same account that we are working on with, and just accept everything anyways and hit this continue. Okay, so for sake of simplicity, select all and hit continue, right? So again, since we are, it will take some time to mount the drive. The time required to mount the drive is completely dependent on as to uh, how or what is the size of the content in your drive. If your drive is full, it might take a longer time for you to get mounted. If there is very little data as it is there in our case, then it will be mounted very effectively, or it will be mounted very easily. Okay, so it will just take some time to your drive to appear in this particular section, right? So for time being, what we can do is that once the drive is mounted, the data will appear over here. Just wait for a while, it might take some time, just a few seconds. Yes, now you can see that the drive has been mounted, right? And in your drive you can see that there are various folders, and whatever we are going to do is present in your MD drive, right? So this is where we are going to work, right? Okay, so now we need another code cell, right? So in this way you need to locate the configuration file, or you can say the path of the configuration file. Meme.conf is the configuration file. So I will right click over here and copy this path, right? And so once I copy this path, okay, one more thing is that first we need to tell as to where is that your NAMD program is located, right? So we need to copy this path first, right? And just paste it over here. Like, first we will give the path to NAMD, right? So where is the path to my NAMD? This is where it is. I will copy the path and simply paste it over here, right? And I will give this exclamatory mark over here so that it will know that we are supposed to run this NAMD program, right? Next I will give this another option, something called as auto provision. This auto provision will make necessary arrangement of using the GPU resources appropriately. Next I need to give the location of my configuration file. I will copy this path and paste it, and then I will give the path where I will save my log file. And once you do this, all you have to do is to run this command. Okay, now your NAMD simulation is running in the background. Okay, now one more thing that I wish to tell you is that I have already mentioned before that Colab is an interactive platform, and it continuously expects communication from the user through code cells. So the thing is that you write the command in these code cells, and if your session remains inactive for a while, then Colab will assume that you are no longer using it, as it and if you are no longer using it, it will log you out and provide the GPU to some other user. So it will eventually give you an error message, or you can say it will provide a runtime disconnect message that might look something like this. Okay, so if you see this type of message, runtime disconnected, that means that you were no longer active for a certain time, and now your connection has been reset and the GPU that you were using has been given to someone else. Okay, so this would mean that all of the work on GPU will be lost and lost after certain inactivity period. So when we run the simulation, it will take some 1 or 2 days to get calculation done. Now to avoid this, we can write a JavaScript that will add a new code cell after every 10 minutes, right? To avoid this thing, what we will do, we will write a JavaScript that will go on adding a new code cell after every 10 minutes, and the Colab will assume that you are continuously giving some input after every 10 minutes. So in this way, Colab will remain interactive and runtime disconnection issue will be resolved. And how is that you do that? I will just introduce you with how is that you can incorporate the JavaScript. For doing that, all you have to do is that you would have to shift this Control Shift and I button on your keyboard. So this will bring out something called as the developers toolbox, and in this developer toolbox we will incorporate our JavaScript in this. Make sure that you are in this console menu of your developers toolbox, and you can write your JavaScript over here. I have already written it. So this is the script that you need to copy and just paste it over here, right? So this is simply a JavaScript that will go on adding a, uh, code cell after after this much interval. This much interval correspond to 10 minutes. So after every 10 minutes a new code cell will be added. Okay, so when this execution happens, now if you even kept it idle for a time being, a new code cell will be automatically added one after another. So I hope it is working now, but Python changes very rapidly, and I really don't know as to for how much days this trick will remain applicable. So if you are watching this video after a few years, maybe this script might not work. You might have to find out some another alternative solution to keep your uh, notebook interactive. Well, anyhow, for time being, it will definitely work. Let us close it. And now you can see the simulation is already done. Okay. So since it is done, well, now it is time for us to compare the performance of this GPU and the CPU that we have done. Okay. So what you can do is that you can simply download this file from your Google Drive, right? Since it is connected, everything is there, right? Now you can see it has been updated in my Google Drive. What I will do from my Google Drive, now I will download my computation, whatever I have done. It is zipping. In this way you can download everything whatever you have performed. So for time being, let us simply download this min.log file so that we can compare the performance. Okay, so this min.log is the file, or this is the log file that has been recently generated on cloud. I will just copy it, right, and paste it over here. Let me rename it as min.log from cloud. Let me edit it in Notepad++ so that we can compare it. Now I have already run the same simulation on my machine, and this is the min.log file. Let us edit it and compare it. So this min.cloud file is the minimization log file that we have obtained from the cloud. Well, now you can see that on this cloud it took only 76 seconds for completion, and when I tried to do it on my PC, the same simulation took me 485 seconds, right? 485 seconds means, well, let us try to convert it into minutes. 485 divided by 60, it took me about 8 minutes to do it on my desktop, while if I use cloud it took only 76 seconds. So you can see that clearly it is 4 times faster, right? So the thing is that you know, it is way too faster. The only thing is that you might have to take care of a few things. Okay, so let us now first discuss what are the pros and cons of using this Google Cloud for performing MD simulation. Let us talk about its good things or pros. The very first thing is that you don't have any need to buy a dedicated and expensive PC for performing MD simulation, right? Second advantage is that you are mobile. You can even do it from mobile if you have proper internet connectivity. So these are two biggest advantage, right? So first, you don't have to buy any expensive PC. It is faster, and you are not dependent on any specific machine you want to use, right? But there are disadvantages as well. So one of the biggest disadvantage is that you have to have continuous internet connectivity in order to keep your notebook alive, right? So continuous internet connectivity is required. If network gets interrupted, the GPU will reset and you will have to start over again, right? Second drawback is that this free version of Google Colab only lasts for 8 hours. So even though if you use GPU for your computation, if you are using this free version of Google Colab, then it will last only for 8 hours. After 8 hours, anyhow, your Google Colab CPU would be reset, right? So you would anyway lose the activity. But we have an alternative for that as well. What you can do is that you can buy a pro plan for in which you can buy this pro plan for just around 1,000 Indian rupees, and they will give you continuous access for 1 month. And considering the speed, it is sufficient for you to run a few hundred nanosecond simulation continuously. So this is it, my friends. In this video I have kind of explained you as to how do you use Google Colab for running MD simulation. Therefore, until next time, happy MD.